The strange thing about plastic is that it does not feel like history while you are living inside it. It feels normal. A bottle cap under the couch, a fork in a takeaway bag, the shell around a remote, the wrap around cucumbers, the clear window in a cardboard box, the tray under the fruit, the foam around a package, the sleeve around a wire, 100 little objects that seem too cheap, too light, too ordinary to carry any real weight in the story of civilization. But they do. Plastic is not just a material. It is a decision the modern world made again and again until it became invisible. We chose speed. We chose convenience. We chose something light enough to ship cheaply, strong enough to survive transport, moldable enough to take almost any form, and cheap enough to flood every shelf in every country. Then we taught supply chains, machines, stores, and habits to depend on it so fully that life without it began to feel unrealistic. That is why the plastic crisis is not really about one straw in the ocean or one bag caught on a tree branch. Those images matter because they sting. But the deeper truth is harder. Humanity now produces more than 400 million tons of plastic every year, and much of it ends up in the environment instead of staying in a useful loop. That is not a side effect anymore. That is the shape of the system. Source. And once you see that, the real question changes. The question is not whether plastic is bad in some abstract moral sense. The question is whether the world can build something strong enough, cheap enough, stable enough, and scalable enough to take meaningful work away from it. That is a much harder fight. Because plastic did not become dominant by being evil. It became dominant by being useful. It showed up where old materials were heavier, pricier, more fragile, or harder to shape. Glass breaks. Metal can be expensive and heavy. Paper wilts. Wood swells and splinters. Plastic arrived like a perfect employee who was willing to do 10 jobs for low pay and never complain. Packaging, consumer goods, industrial parts, casings, coatings, connectors, trays, wraps, housings, toys, dashboards, liners, bottles. One material walked into all those categories and said yes, and for decades that yes was enough. Then the bill came due. The same qualities that made plastic brilliant in a factory made it brutal in a dump. The material lasts. It persists. It does not politely disappear after serving its short little purpose in human hands. It lingers. It breaks into smaller pieces. It drifts across rivers and coastlines. It moves through soil and marine systems. It enters places it was never invited to go. OECD data showed global plastic waste more than doubled from 2000 to 2019, reaching 353 million tons, while only 9% was recycled after accounting for system losses. The rest was landfilled, incinerated, or leaked into the environment. Source. That is why replacing plastic is one of those challenges that sounds simple only from far away. Up close, it is vicious. A replacement cannot just be greener in a headline. It has to survive the ugly details of real life. It has to endure pressure, stacking, heat, moisture, storage, transit, handling, machine tolerances, shelf time, and customer abuse. It has to work when a warehouse is hot, when a truck is late, when a lid is forced, when a child drops it, when a buyer compares invoices at the end of a bad quarter. It has to fit into manufacturing rhythms that have been trained for decades around petroleum-based materials. A substitute does not compete with plastic in theory. It competes with plastic on a Monday morning inside a real production schedule. That is why so many green replacements disappoint people. Some biodegrade, but only under highly managed industrial composting conditions. Some come from crops that raise uncomfortable questions about land and food. Some are decent for low-stress uses, then fail in heat or humidity. Some work beautifully in prototypes and become a nightmare at scale. Some look sustainable until you inspect the energy or chemistry required to make them. Some are so expensive that they survive only as branding tools for premium companies selling virtue to affluent shoppers. So whenever a new material claims it can challenge plastic on performance, skepticism is not cynicism. It is discipline. And that is exactly why the recent bamboo story matters. In 2025, a study published in Nature Communications described what the authors called bamboo molecular plastic, or BM plastic, made through a solvent-mediated molecular engineering strategy. The claims were not small. The paper reported an ultimate tensile strength of 110 MPa, thermal stability above 180 degrees Celsius, full biodegradation in soil within 50 days, the ability to retain about 90% of mechanical properties after recycling, and compatibility with conventional manufacturing methods such as injection molding and machining. Those are the kinds of numbers and process claims that force people to stop treating a material like a novelty and start treating it like a contender. Source. To understand why that matters, It helps to slow down and look at what bamboo really is in this story. Bamboo is not magical. It is not a moral object. It is a plant. But it is a plant with a very useful profile for a world desperate for alternatives. It grows fast. It is renewable. It already has industrial familiarity in many parts of Asia. And inside it is cellulose, one of the most important structural materials nature ever invented. Cellulose is what helps plants stand, stretch, and hold shape. It is one of the basic load-bearing tools of the biological world. That sounds abstract until you picture it properly. Think of cellulose as a mass of incredibly small threads bundled inside plant matter. Not loose threads, but threads caught in a dense internal social life. Their chains cling together through hydrogen bonds, which you can imagine as millions upon millions of tiny handshakes. One handshake is weak. A crowd of them becomes a system. That system is part of what gives plant fibers their toughness and stubbornness. Now here is the trick. If those inner threads stay locked in their original plant arrangement, they are not automatically ready to become a high-performance industrial material. Nature built them for a stock, not for a molded consumer part. So the challenge is not simply harvesting bamboo and calling it plastic. The challenge is persuading plant structure to reorganize itself into something with the internal order, density, and processability industry needs. According to the Nature paper, that is what the researchers were trying to do. They used a solvent-mediated process and ethanol-assisted shaping to tune the hydrogen bond network of bamboo cellulose. In simpler language, they loosened the original molecular arrangement enough to let the material be reshaped, then guided the cellulose chains back together in a denser and more effective structure. The result was not just bamboo fiber pressed into a sheet, it was a molecularly reorganized material designed to behave like a serious engineered plastic alternative. Source. That difference is everything, because the future of sustainable materials will not be decided by sentiment. It will be decided by inner architecture. The world does not reward good intentions for very long. A package either survives transport or it does not. A tray either stays stable under heat or it warps. A casing either protects the object or cracks. If you want to displace even a fraction of petroleum plastic, you need a material whose microscopic order translates into boring reliability in ordinary products. The invisible structure becomes the visible outcome. That is one reason the thermal claim in the paper matters so much. The authors reported thermal stability above 180 degrees Celsius. That is not just a nice extra. Heat tolerance is one of the points where many alternative materials lose the fight before it begins. A material can be compostable, renewable, and beautifully marketed, but if it softens too early or becomes unreliable under manufacturing temperatures or high-use settings, it gets pushed into a narrow niche. It becomes the kind of thing people use for symbolic products, not serious ones. High thermal stability does not guarantee market success, but without it, many markets never even open. Source. The strength claim matters for the same reason. The paper says BM plastic exceeded the properties of materials like high-density polyethylene, acrylonitrile, butadiene, styrene, and commercial bioplastics such as PLA in key ways, with a reported ultimate tensile strength of 110 MPa and a Young's modulus of 2.2 GPa. Strip away the jargon, and the message becomes simple. This was not being presented as a gentle, fragile substitute for low-stakes eco-products. It was being pitched as a high-performance material. Source that is a psychological shift as much as a technical one. Most people have been trained to expect green materials to come with apology in the box. Better for the planet, maybe, but weaker. Kinder, but less durable. Cleaner, but somehow unfinished. We have been taught to translate sustainability into sacrifice. Use the more ethical option and prepare for it to be uglier, softer, pricier, or less reliable. A material like this challenges that emotional script. It suggests that the next era of sustainable materials may not win by asking people to tolerate less. It may win by delivering something that feels fully modern, fully capable, and more aligned with what the waste crisis now demands. That is a powerful idea because adoption is not only about engineering, it is also about dignity. Manufacturers do not want to feel like they are downgrading. Consumers do not want to feel like they are being punished. A substitute that feels competent changes the mood of the entire conversation. Then there is the end-of-life question, the question that now haunts every material trying to inherit part of plastic's kingdom. What happens after we are done with it? This is where the Nature paper made its strongest emotional move. The study reported that BM plastic fully biodegraded in natural soil within 50 days. At the same time, it also reported closed-loop recyclability, with the recycled material retaining about 90% of its mechanical properties. In other words, the material was presented not as something trapped in a single moral lane, but as something flexible, recyclable when collection and reprocessing systems exist, degradable in soil when it truly escapes into the environment. Source. The combination is rare. Usually, materials make you choose your disappointment. Either they are durable enough for practical use but stubborn at the end of life, or they break down nicely but are too weak, too unstable, or too expensive for demanding applications. Or they can be recycled, but only under conditions so costly or inconvenient that the circularity exists mostly in presentations and policy language. What makes the bamboo case exciting is not that it has already solved all of this beyond dispute. It is that it appears to be aiming at the right balance, useful enough to matter, circular enough to change the waste story, familiar enough in origin to scale in regions where bamboo is already part of the economic landscape. That wider landscape matters more than most breakthrough headlines admit. Materials rarely win on science alone. They need roads to market. They need standards, tooling, buyers, regulations, investors, testing pipelines, and supply narratives. A better material can still die if it cannot find a place inside the choreography of commerce. History is full of technically promising things that lost because the surrounding system was not ready to carry them. This is one reason the bamboo push in China deserves attention beyond the lab itself. In 2022, China and the International Bamboo and Rattan Organization launched the bamboo as a substitute for plastic initiative, often shortened to BASPO. According to Ecobusiness, the initiative aims to use bamboo to reduce plastic pollution, address climate change, and support the UN's 2030 Sustainable Development Agenda. In 2023, a major symposium helped push the effort forward, and a global action plan was released as a framework for coordinating and scaling international action. The Chinese domestic plan, as described there, focused on daily necessities, industrial products, and architecture and building materials. Source. That means the bamboo material story is not floating alone in scientific air. It sits inside a bigger policy and industrial imagination. And that matters because one of the hardest parts of replacing plastic is not inventing a material. It is creating a believable path by which businesses can imagine adopting it. Policy signals, industrial initiatives, and public narratives lower the psychological cost of switching. They tell manufacturers that they are not stepping into an eccentric niche alone. They are entering a lane that governments, trade groups, researchers, and procurement systems may actively support. UNEP WCMC described bamboo and rattan as part of a nature-based response to plastic pollution, and noted that replacing plastic with bamboo was launched as an initiative aimed at reducing plastic pollution and finding pathways to mainstream bamboo as a viable alternative. That wording matters. Mainstreaming is different from showcasing. A showcase product is a symbol. A mainstream product is infrastructure. Source. And if you want to understand how material revolutions actually happen, that distinction is everything. We like to imagine revolutions as dramatic. A new object appears, the old one dies. Everyone notices. Real material transitions are usually quieter and much more stubborn than that. They happen through procurement departments, standards committees, cost curves, tooling updates, stress tests, and millions of small purchasing decisions made by people who are not trying to change history at all. They are just trying to meet a deadline without getting fired. Plastic itself took over this way. It did not conquer the world because everyone woke up one day in awe of polymer chemistry. It conquered the world because it kept being good enough in one use after another. Good enough for packaging, good enough for toys, good enough for consumer parts, good enough for disposable items, good enough for shipping, good enough for trim pieces, good enough to build whole supply chains around. A serious alternative will probably rise the same way. Not all at once, not everywhere, not by replacing every use, just by starting to steal categories one by one. And that is why bamboo might have a real opening. Not because anyone sensible thinks it will replace every plastic application from medical devices to aerospace components. It will not. The smarter ambition is narrower and more powerful. Push plastic out of the jobs it should never have dominated so easily. Start with categories where petroleum plastic is strong but not irreplaceable. Move into products where heat resistance, structural integrity, and manufacturability matter, but where full fossil dependence is not actually necessary. That path is much more believable. Imagine the market in layers. At the easiest layer, you have visible consumer goods where people already expect alternatives, utensils, packaging accessories, basic household items. At the next layer, you have rigid packaging, trays, lids, shells, and durable components that require better performance. At the harder layer, You have interior panels, appliance housings, and semi-structural consumer parts. The deeper bamboo-based materials can travel into those middle layers, the more meaningful the substitution becomes. And here, the processability claim in the Nature paper becomes almost as important as the strength claim. The authors said the material could be fabricated at scale with intricate 3D geometries under ambient conditions, and was compatible with conventional manufacturing processes like injection molding and machining. That is not a decorative claim. It speaks directly to the bridge between laboratory material science and factory life. A material that can only exist as a lab sheet remains a curiosity. A material that can move through familiar shaping processes starts to become economically legible. Source. Still, this is exactly the point where honesty matters most. A good paper is not the same thing as a settled future. The graveyard of materials science is full of beautiful results that never found durable commercial life. Sometimes the bottleneck is cost. Sometimes the chemistry scales badly. Sometimes the feedstock quality varies too much. Sometimes the process is slower or dirtier than early excitement admits. Sometimes the performance depends on conditions too controlled to survive real manufacturing. Sometimes approvals take forever. Sometimes industries simply refuse to retool until pain becomes impossible to ignore. So no, bamboo plastic has not won. Anybody saying that already is selling excitement too cheaply. But it may have done something more valuable at this stage. It may have passed the first threshold that separates fantasy from serious attention. It may have shown enough performance, heat tolerance, circularity, and process compatibility to force harder questions. Not, is this cute? But what applications are now plausible? Not, would consumers like the idea? But what would it take to qualify this for actual product lines? That is a stronger conversation. And it comes at the right moment. Because the old plastic bargain is looking worse every year. UNEP says the world produces more than 400 million tons of plastic annually. OECD says plastic waste hit 353 million tons in 2019, and only 9% was recycled. Those are not just environmental numbers, they are numbers of system failure. They reveal a civilization that became expert at distributing material, but remained dangerously weak at retrieving, reusing, or replacing it. Source. That is why alternatives now matter in a deeper way. For years, society treated waste mostly as a downstream cleanup problem. Recycle more, pick up litter, improve collection, penalize visible pollution. All of that matters. But the scale of the numbers tells a more brutal truth. You cannot solve a design problem entirely at the dump. If the world keeps feeding itself enormous volumes of cheap, persistent material intended for short lives, then downstream systems will always be choking on upstream choices. So a material like bamboo plastic becomes important, not because it is perfect, but because it changes the upstream menu. It says, maybe the future is not only about cleaning after petroleum plastic better, maybe it is also about shrinking. The territory petroleum plastic gets to control in the first place. That is a very different kind of hope, not magical hope, structural hope. Still, bamboo has its own risks, and serious people should say them out loud. Any raw material can become destructive if demand outruns discipline. Rapid growth is not the same thing as responsible land use. A bamboo boom, handled badly, could still create monoculture pressures, poor harvesting practices, ecological simplification, or extractive rural economics that sound green in cities while becoming messy on the ground. A plant-based material does not get automatic moral immunity simply because it starts in the soil rather than a barrel of crude. This means the future of bamboo plastic is not only a chemistry story, it is also a governance story. Where is the bamboo grown? Under what land use rules? With what biodiversity safeguards? Under what labor conditions? How is processing handled? What chemicals are used, and what emissions or residues accompany them? Is the full life cycle honestly assessed or selectively framed to flatter the headline? Those questions are not attacks on the idea. They are the price of taking it seriously. A weak idea collapses under scrutiny. A strong idea survives it, and if bamboo-based materials are going to move from paper to procurement, they will need to survive a lot of scrutiny. Manufacturers will ask whether the material stays consistent across batches. Safety regulators will ask how it behaves in food contact applications, under heat, oils, acids, and time. Product designers will ask about finish, texture, color stability, and dimensional control. Waste managers will ask what biodegrades in soil really means in mixed, messy, real-world disposal conditions. Investors will ask about margins. Buyers will ask about price volatility. Every one of those questions is legitimate. This is why the most promising part of the bamboo story may not be the emotional appeal of bamboo itself. It may be the posture of the research. The Nature paper did not market the material as a moral token. It presented it as a performance material with circular potential. That matters because the world does not need more symbolic alternatives that make people feel temporarily cleaner while leaving the core economics untouched. It needs candidates that can enter the brutal practical contest that plastic has ruled for decades. If BM plastic or materials like it keep proving themselves, the consequences could extend beyond one class of products. They could change how the world thinks about plant matter itself. For a long time, industrial modernity treated plants in two main ways: as food or as fuel, with some timber, paper, textiles, and specialty materials around the edges. But the deeper lesson of advanced biomaterials is that plants may also become engineered structural feedstocks for a new manufacturing era. Not primitive substitutes, not nostalgic throwbacks. Advanced, tuned materials born from biological architecture and molecular control. That is a bigger story than bamboo alone. It is the story of whether the next material century can learn from biology without romanticizing it. Because nature has always built with astonishing efficiency. The challenge for industry is not worshiping that fact. The challenge is translating it into scalable systems that meet human needs without extending the waste logic that plastic exposed so painfully. China's bamboo push matters in that context because it offers a possible model of how such translation happens. Not automatically, not cleanly, but plausibly. Policy support, research emphasis, industrial targeting, and resource availability are all lining up around the idea that bamboo can be more than a traditional material. It can be industrial feedstock. Eco-Business described the Chinese plan as targeting daily necessities, industrial products, and building materials, which shows the ambition is not limited to ornamental green consumer goods. Source. If that alignment holds, China could do what it has done in other sectors before. Move from concept to manufacturing scale with unusual speed, learn through production, compress costs, and influence standards through volume. That possibility should not be ignored. Many technologies look niche until one country decides to build the industrial muscle around them. Then the rest of the world discovers that what seemed experimental has become commercially unavoidable. And if that happens, bamboo's image could change globally. Right now, many people in industrialized markets still associate bamboo with niche eco-products, resort furniture, craft goods, toothbrush handles, or premium green lifestyle branding. But history loves reversals. Materials once dismissed as humble can become central when conditions change. The future may look back and see bamboo not as a soft symbol of sustainability, but as one of the serious workhorse feedstocks of a post-petroleum material transition. That would be a profound cultural shift. Because plastic changed more than manufacturing. It changed imagination. It made disposability feel modern. It made abundance feel weightless. It let societies behave as if matter itself had become almost consequence-free. Use it quickly, replace it easily, wrap everything, protect everything, ship everything, throw away the container and keep the convenience. The plastic age was not only a material era, it was a psychological era. A bamboo-based alternative, if it truly scales, would help write a different psychological era. One where high-performance materials do not have to begin in fossil feedstock. One where circularity is not a heroic afterthought. One where disposability loses some of its glamour because durable, processable, biologically rooted materials start competing for the same space. That does not mean a pure or simple future. There will still be mixed systems. There will still be fossil plastics in many critical uses. There will still be compromise, trade-offs, failures, greenwashing, partial wins, and unintended consequences. But history does not require purity to change direction. It just needs enough pressure in the right places. And bamboo might apply that pressure in exactly the way modern materials markets understand best, not as guilt, but as competence. That is what makes the image of the test machine so powerful. Not because a strip of pale material is visually dramatic, it is not, but because that kind of machine asks a blunt question that cuts through marketing. Can this hold? Can it survive force? Can it take stress? Can it belong in the adult world of engineering rather than the children's corner of eco-dreams? For a long time, petroleum plastics answered that question more convincingly than almost any rival. The deeper challenge now is answering the next question too. What happens after the useful life ends? That is where the old kingdom looks weaker than it once did. A material that wins on strength but loses catastrophically on afterlife is no longer winning cleanly. The world has learned too much. We have seen the scale of production. We have seen the waste climb. We have seen recycling fall short of the myth that surrounded it. We have seen how persistence turns convenience into inheritance. Source. So maybe the real value of bamboo plastic is not that it promises to erase plastic from history. Maybe its value is that it helps narrow the empire. That may sound less heroic, but it is actually more believable. Push petroleum plastic out of single-use goods where alternatives can compete. Push it out of selected, rigid packaging. Push it out of some housings, trays, shells, and interior parts. Push it out of product lines where the environmental cost of persistence is hardest to justify, and the performance requirements are no longer safely monopolized by fossil-based polymers. That is how curves bend, quietly first. A few categories, a few supply contracts, a few manufacturing lines, a few retail decisions. Then the numbers start to move, then familiarity shifts, then what once felt risky starts to feel ordinary. Then the old material keeps losing small battles until people forget how dominant it once seemed. Most of the biggest changes in material culture arrive disguised as boring substitutions. One day the produce tray is different. The lid feels the same, but it came from another feedstock. The appliance shell still looks ordinary, but the chemistry of the ordinary has changed. The panel in a budget vehicle no longer begins in crude oil. The packaging line still runs on time, but the waste story at the end is less punishing. The consumer does not gasp. The object does not announce itself. History moves anyway. That is the kind of future bamboo plastic is trying to enter, a future where the most powerful, sustainable materials do not need to look radical. They only need to work. And maybe that is the deepest reason this story lands so hard. We are used to imagining environmental change as sacrifice, restriction, and visible moral effort. Use less, consume less, give up more. Those conversations matter. But materials innovation offers another route too. Redesign the physical defaults of modern life so that better outcomes are built into ordinary use. Not because people became saints, because the material underneath the routine changed. If bamboo-based plastic reaches that point, it will not simply be a nice invention. It will be one answer to a civilizational embarrassment. We built a world around a substance that was excellent at entering our lives and terrible at leaving them. The task now is not only to clean up the mess, but to create successors worthy of taking over the jobs we assigned so cheaply and thoughtlessly. That is a high bar. But for once, bamboo does not look like it is approaching that bar as a weak substitute asking for mercy. It looks like it may be approaching as a material with an argument. A practical argument, a strength argument, a thermal argument, a circularity argument, and maybe, if future testing and scaling keep supporting it, a market argument. That is when things get dangerous for old incumbents. Not when a rival sounds morally superior, but when it starts sounding operationally credible. So no, the honest line is not that bamboo will kill plastic by itself. The honest line is tougher and more interesting than that. It is that the age of assuming oil-based plastic deserves every category it occupies may finally be ending. And once that assumption breaks, the door opens wider than people think. Because then every object becomes a question again. Does this really need fossil feedstock? Does this really need centuries of persistence? Does this really need the old bargain? And if the answer starts becoming no in enough categories, then the future changes one ordinary object at a time. A tray, a shell, a lid, a panel, a handle, a housing, a box, a part. 1,000 boring wins that add up to something historic. That is how material empires fade. Not always with collapse, sometimes with replacement, sometimes with competition, sometimes with a pale strip of engineered bamboo in a testing machine, enduring force long enough to make a room go quiet.